In this video, we're going to talk about an example of finding a tangent line parallel to a given plane. All right, so we've got a point on the curve. We want to find a point on the curve, rather, where the tangent line to the vector-valued function 2 cosine t, 2 sine t, e to the t is parallel to the plane root 3x plus y equals 0. All right, so we know we want a tangent line, so we're going to take a derivative of this vector-valued function. The derivative here is going to be negative 2 sine t, 2 cosine t, and e to the t for our vector-valued derivative, if you will. This gives us the direction vector for the tangent line, which we want to be parallel to the plane. Well, if it's going to be parallel to the plane, it better be orthogonal to the normal vector of the plane. Well, we can read the normal vector off from using the direction, or the coefficients on the x and y and the z for the equation of the plane they give us. So the normal vector to that plane must be root 3, 1, 0. So since we want the direction vector to be orthogonal to the normal vector, we can take the dot product and set it equal to 0, and then solve for t. All right, so when we take the dot product here, we'll get negative 2 root 3 sine t plus 2 cosine t, and then plus a 0 equals 0. Dividing through both sides by cosine of t, and being mindful that we probably don't want t to be pi over 2, because otherwise this would make this 0, and we divide both sides by 0. We divide by cosine of t, 2 cosine t, and solve for tangent then. We get tangent of t is 1 over root 3. We want the value of t that solves this between 0 and pi, because the problem says restrict our values between 0 and pi. The value of t that'll give us this tangent will be pi over 6. When we plug in pi over 6 for the vector valued function, the point on the curve here will be root 3, 1, and e to the pi over 6. And you can see here in this example, here's the plane, root 3x plus y equals 1. It's a little hard to tell, but this tangent line is parallel to that plane. And here is the graph of a piece of that particular curve.